All right, the purpose of this video is to reacquaint you with the idea of slope and talk about how that has a relationship with parallel lines and perpendicular lines. Hopefully, a lot of the material that you're going to see in the video today you'll remember from your algebra class, but if not, it's a chance and an opportunity for you to reacquaint yourself with the information and apply it to the geometry that we'll be doing this year. Just a reminder, as you watch this video, please, please, please don't be watching the video to make me happy or to satisfy me or because you know that I'm going to check your homework tomorrow, but rather I hope that your point and your purpose in watching this video is so that you can acquire the knowledge and skills that you need to be successful in class the next time that we come to class and on future tests and quizzes. So again, I hope you're watching this video with that in mind, and then we'll proceed from there. So number 1 says we're given point A with coordinates 2, 2, point B with coordinates 4, 6, point C with coordinates 6, 4, and point D with coordinates 7, 6. Letter A, it says graph line AB and line CD using the graph provided. So in order to graph those lines, I'm going to go ahead and I'm going to plot those points on the coordinate axes. So A has coordinates 2, 2, and it's going to be right about there. B has coordinates 4, 6. He's going to be right about there. And I'm going to go ahead and plot and label. I'm going to grab my straight edge. And graph that line. I'm going to add a couple arrows to the end of it. So there's line AB. Line CD I'm going to graph by plotting point C. So there's point C, point D, and again I'm going to go ahead and grab my straight edge and connect those points. So now I've successfully graphed line AB and I've successfully graphed line CD. Part B wants us to find the slope of line AB. Recall from last year that slope is equal to change in y, or y1 minus y2, over x1 minus x2. Now this year I might write that a little bit differently. I'm going to say the change in the y values over the change in the x values. Since I'm trying to find the slope of AB, for the time being I'm going to ignore the coordinates of point C and the coordinates of point D. The y values for point A are 2 and for point B is 6. So I'm going to go ahead and write that as 6 minus 2. So the y value for B, subtract the y value for A, over the change in the x's. So the x value for B is 4, the x value for A is 2, so I'm going to say 4 subtract 2. Since I put the y value for B first, I must put the the x value for B also first. And this should be review from last year. So 6 subtract 2 is 4, 4 subtract 2 is 2. Written as a fraction in simplest form, the slope of line AB is 2 over 1. I'm going to go do the same thing now for CD. So slope, change in y over change in x. And hopefully you've seen the Greek letter delta before. If not, it's just a Greek letter that stands for change in. It's a symbol. I'm going to uncover those for C and D. And at this point, I'm not going to worry about coordinates A and B, so I'm going to put those out of sight, out of mind. I'm going to pay attention to C and D. So 4 subtract 6 for my change in y. Since I used the y value of 4 first, I need to use the x value of 6 first. So 4 subtract 6 is negative 2. 6 subtract 7 is negative 1. Negative divided by a negative is a positive, which makes these guys 2 over 1. Notice that the slope of each line is exactly the same. And if I go look at where I graph these guys over on the coordinate plane, it just so happens that these two lines are parallel. And so the idea, or the big key idea that we want you to pull away from this video, is that two lines are going to be parallel to each other if and only if they have the same slope. So this, I'm going to pull out my pen, key idea. I don't know, apparently the ghost has come in and taken over my computer again because it's going out of control and doing all sorts of funky things. Two lines are parallel if and only if they have the same slope. That's big. That's so big, I'm going to go ahead and get my funky pen out, and I'm going to put stars around it. That's going to be a really important idea for us as we move forward through the geometry curriculum this year. All right, so down at the bottom, number 2, it says, given the coordinates of those points, use their slopes to determine whether or not they're parallel to each other. So the first one I'm going to take a look at is I'm going to look at line AB. Line AB, I'm going to go ahead and use those coordinates in order to find slope. Anytime I use a formula in this course, I'm always going to write it down first. So I'm going to start by writing down slope is equal to change in y over change in x. The two y values are 5 and 9. Since I put or used this y value first for A, I must use the x value first for A. So this ends up being -4 over -2, which will simplify or reduce down to 2 over 1. Now I'm going to go do the same thing, but I'm going to go find the slope of CD. And since I'm finding slope twice in the same problem, I should identify on my paper that this first one that I found the slope for was line AB. The second one that I'm finding slope for is CD. I think I'll color code these. I already wrote the formula down once, so I'm not going to write it again. And that fraction will simplify down to 2 over 1. So when all is said and done, I have to make sure I answer the question. They wanted me to determine whether or not the two lines were parallel. So when I compare their slopes, I find that their slopes are indeed the same, which means they are parallel. So yes, line AB is parallel to line C because they have the same slope. Now that connection between parallelism and slope is something that you should have seen before last year in your algebra class. It shouldn't be anything that's new. But in the event that it is new, now it's something that you kind of have in the back pocket, and it's a tool that you can use. Up at the top of the next page, they're asking us to determine whether or not the following pairs of lines are parallel, and then justify your answer. So what they're really asking us to do is find out if they have the same slope. So I'm going to go compare slopes of each of these lines. And in order to do that, remember when a line is written in the form y equals mx plus b, the number that you see in front of m represents the slope. The number that you see at the end, the b, represents the y-intercept. Now, the connection between parallel and slope is that lines are parallel when they have the same slope. The y-intercept has nothing to do with whether two lines are parallel or not. So the only thing I'm going to pay attention to in this particular example is the slope. Not the same slope, not parallel. So my reason, they do not have the same slope. These two guys, if I compare their slopes, they're the same. That's going to make them parallel. Note that in number 5, this first equation isn't written in the form y equals mx plus b. This is not solved for y. So the first thing I need to do is go divide each and every term in the equation by 2 so that I can go ahead and make that comparison. So now that I've gone ahead and solved for y, it's fair game to go ahead and make that comparison. When I compare their slopes, I find that they are the same, making the two lines parallel. All right, I'm not quite sure what happened to number 6, but the ghost must have gotten it, so we're going to move on to number 7. Number 7 wants us to write an equation of the line passing through the point whose coordinates are 2, 3, and parallel to the line equals y equals minus 2x minus 5. So in this particular case, I know that I want my slope to be negative 2. I want it to match up with this guy over here. I know that I want my line to pass through this point. So I've got a point and I've got the slope. I'm going to use the point-slope form of an equation. Point-slope form of an equation says y subtract y1 is equal to m times x subtract x1, where x1 and y1 are the coordinates of the point we want our line to pass through. So this guy over here is my x1, this guy over here, my y1. So I'm simply going to go plug in y subtract the y coordinate, 3, is equal to our slope, negative 2, times x subtract the x coordinate, which is 2. Now, at this point, you're done. You don't have to do anything more to it. And somebody's going to say, but Mrs. McCann, that equation has x's and y's in it. Well, if I look at that one that I was given, the y equals negative 2x minus 5, this guy has an x in it. He has a y in it. They're supposed to have an x and a y in it when you're done. If you're really uncomfortable seeing it written in this form, feel free to go ahead and distribute the negative 2 on the right-hand side. And then we can go ahead and add 3 to both sides. And if you're more comfortable seeing it in that form, you're more than welcome to express it this way. But these two lines are two different ways of writing the exact same line. And unless it specifies, you're more than welcome to express in either way. Either answer is correct. All right, number 8 says write an equation of the line parallel to the line whose equation is y equals 2x minus 3, passing through the point whose coordinates are negative 1, negative 4. So since I want it to be parallel to this guy, I know I want my slope to be 2. I want it to pass through that point. So again, I've got a point, I've got a slope. I'm going to write my equation using the point-slope form of a line. Y subtract y1 equals m times x subtract x1. And again, the coordinates of my point become my x1 and my y1. So I've got y subtract a negative 4 equals 2 times x subtract a negative 1. I don't like the subtract a negative. It's not clean, it's not nice, it's not very concise. Same with subtract a negative 1, so I'm going to clean that up a little bit. And there's my answer. I'm done. I don't need to do anything more to it. If you want to, if you're dying to put it in the form y equals mx plus b, then you're all set to go ahead and manipulate it algebraically if you'd like, but it's certainly not a requirement. So again, these are two different ways to express the same line, and you're able to express the equations however you'd like. Okay, hopefully you remember from last year also the deal with perpendicular lines. If you don't, here's your little crash course right now. We say two lines are perpendicular if and only if their slopes are negative reciprocals. Now this is going to make sense to you only if you know what it means for two numbers to be negative reciprocals. We're going to take a minute and discuss what that means just so that there's no doubt in your mind. I guess the numbers I'm going to pick, let's say 2/3 and 3/2. 2/3 and 3/2 are reciprocals. So that takes care of the reciprocal part of the problem. In order to be negative reciprocals, one of the numbers has to be positive, the other one has to be negative. I don't know why they call them or don't call them opposite reciprocals. If I was the one making the rules, I would have called these opposite reciprocals, but the correct mathematical terminology is to say that they are negative reciprocals. But again, all that word negative is referring to is that they have opposite signs. One's got to be positive, the other one's got to be negative. So up at the top of the next page, when they're asking us or giving us these equations and asking us whether or not they're perpendicular, all we're going to do is we're going to look at them and we're going to decide whether they're negative reciprocals or not. So in this particular case, I'm going to turn this one into an improper fraction. We've got 2/1, 1/2. They are reciprocals. However, we don't have one positive and one negative, and they are therefore not perpendicular. Number 2, this guy's a -1/2. This guy's a 2/1. So again, I've got two numbers that are reciprocals, where one is negative, the other's positive, making these two guys perpendicular. Number 3, again, I'm going to put that first number over 1 to turn it into an improper fraction. So these guys are reciprocals of each other. I've got one that's positive, one that's negative, making them negative reciprocals. That's going to make them perpendicular. And I can go on and do the last two in a similar fashion. These guys can't be perpendicular because they both have the same sign. These guys are perpendicular. And then the last one is kind of interesting. That definitely bears some looking at. I'm going to put them both over 1. So they are reciprocals. I do have one that's positive and one that's negative. And that does make them perpendicular. All right, in the interest of time, I'm going to skip over 1, 2, and 3 at the bottom of the page. But again, they're asking us if these lines are perpendicular. So that's really just a fancy way of saying, do they really have slopes that are negative reciprocal? And if the answer to that question is yes, then we would say they're perpendicular. If the answer to that question is no, then they're not perpendicular. I want to get to the fun stuff at the top of the last page, though, and that is writing the equations of the line. It says, write an equation of the line perpendicular to the given line, passing through the given point. Then it goes on to say, graph the line that is given and the line that you find. All right, so I know that perpendicular lines have negative reciprocal slopes. I'm going to start out by looking at this guy. He has a slope of 1/3. I want to use in my equation the slope of a line that's going to be perpendicular to that. The notation that I'm going to use is the m for slope and then the little subscript for perpendicular. So if this guy has a slope of 1/3, his perpendicular buddy must have a slope of -3/1. So -3/1 or just -3 is the number that I'm going to use in my equation. So now I've got the coordinates of a point. I've got the slope I want to use. I'm all set up to go ahead and do the slope point slope form of a line. So I've got y subtract y1 equals m times x subtract x1. So y subtract my y coordinate, which is 5. My slope, -3, times x minus my x coordinate, which is 0. I'm all set to leave it like that if I want to. But if it makes you feel more comfortable, go ahead and distribute. And you end up with y equals -3x plus 5. Again, either one of those are acceptable answers, and you do need to be able to recognize that they are one and the same. All right, last one. This one gives me the point 4, -6, the equation. I'm going to go ahead and start by looking at that 2. So my slope of the given line is 2. Slope of a line perpendicular, going to be -1/2. So I want my line to pass through that point with that slope. So y subtract y1 equals m times x subtract x1. So I've got y subtracted negative 6, which is a real ply plus 6, equals my slope, negative a half, times x subtract 4. If it were up to me, I'd leave it right there. I understand, though, that some of you are much more comfortable leaving it in the form y equals mx plus b. So if you are, I'm going to go ahead and distribute on the right-hand side. So a minus 1/2 times a minus 4 is a plus 2. And when all is said and done and I subtract 6 from both sides, I end up with y equals minus a half x plus 4. Or sorry, y equals a minus a half x minus 4. We'll practice more with these the next time you come back to class. As always, if you have questions, feel free to jot them down in the margins or shoot me an email.